Hey guys, can you believe it's already Wednesday? Listen, I know you have 2 days to do this, and so what I'm going to do is I'm going to try and go through as many of the problems as possible because I do want you to work on the function assignment from USA Test Prep. You'll notice that I start all of the slides with the exponential rate for either growth or decay formula, okay? So let's take a look at this first one. If you have an account balance and it starts with $100 and has an annual rate of 4%, the money left in the account after 12 years. Well, the population, of course, will be a principal of $100. And then don't forget that the rate is 4%, 0.04. And then, of course, the account for 12 years. Our time for this one is in years, okay? Now, one of the things that you'll be asked on the EOCT is factors that are not dependent on each other. And please realize that this expression, the 1 and 400ths, is added together. That sum does become 1.04. And then remember that the power of 12 is only applied to the 1 and 400ths. When you put this into the calculator and you have 100 times 1 and 400ths raised to the power of 12, you get an answer that looks like this: 160.103229. And basically what you need to remember with that is this: the amount in the account after 12 years will be $160.10. What about this one? In 1985, there's 285 cell phone subscribers in the small town of Centerville. The number of subscribers increases by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? Well, one of the things that you have to remember, guys, is the time is in years, but we want to remember that 1985 actually is year zero, okay? So 1994 minus 1985 is 9 years. And so what we're going to do is the initial population is 285. The rate of change is 75%, which becomes 7,500ths. And we're raising this to the power of 9. Again, that factor becomes 1 and 7,500ths. The power of 9 is applied only to that. We put it into the calculator, and we get 43,871.98. Now, ladies and gentlemen, this is cell phone subscribers. You cannot have a partial subscriber. And so, ladies and gentlemen, I would have accepted that you had changed this to 43,872, but I would have been much happier if you had realized that 43,871 is the more specific, accurate, precise answer. And of course, this is at the end of 1994. Problem number 3. This is a power function because you're starting with 1 bacteria. It doubles every hour. How many bacteria will you have at the end of 1 day? Okay? So remember, we are starting with a population of 1. Double rate is 2 raised to the power of 24. And when you put it in the calculator, you get that. And so at the end of 1 day, you would have 16,777,216 bacteria. My goodness, I hope that's not deadly bacteria. Also, please realize that the time raised to the power of t was in hours, not in days. All right. Here we go with an exponential decay. We have a tennis tournament. Play starts with 128 participants during each round. Half of the players are eliminated. How many players remain after 5 rounds? This is kind of like the M&M lab that we did. Okay, hopefully you knew what P, R, and T were. And the population that you started with was 128 players. The rate of change that you're going to lose is 50% because that is half of the players. And time is not really time, it's number of rounds, which is 5. We go ahead and do that as 128 times 500ths raised to the power of 5. And when you do that, you have 4. And so, ladies and gentlemen, 4 players will remain after this round. What about this one? Winupmaka. Nevada can be modeled by population equals 6191 times 1 and 400ths raised to the power of t. T is the number of years since 1990. What was the population in 1990? By what percent did the population increase by each year? This is to tell if you know what the formula represents. Hopefully you knew that the population in 1990 was 6191. That's where time would be equal to 0. And the percent rate of increase is 4%. Notice that we wrote it as a percent and not as a decimal. What about this one? Hopefully you realize that, boy, your land value is going to be great. But if you purchased it in 1960, you'd be as old as Mrs. Rose. But since you're not, you inherited that land that was purchased in 1960. The value of the land increased by approximately 5% each year. What is the approximate value of the land in the year 2011? Well, hopefully you knew that you were going to use the exponential growth model. Hopefully you knew that the population wasn't actually, it was a population, it was dollar amount of 30,000. And 51 years from 1960 to 2011. And we go ahead and set it up like this. Put it in the handy dandy calculator. And we know it's a monetary amount, so the land is worth $361,223. Notice that because of accuracy and precision, it started with an approximate land value of $30,000. You wouldn't bother to put the cents at this point. What about this one? This one's really interesting. This is where science and math kind of collide. 12% of the air of your lungs is replaced after one breath. And this is an exponential decay model. And to find out the original air left in the lungs, if you started with 500 milliliters and after 240 breaths, so notice that T isn't really T, time, it's B, breaths. You start with 500 milliliters. You subtract 12%, which of course in decimal format is 1200ths, and you raise it to the power of 240. And you get this. Oh, there's that E again, and I hope that your calculator had the E. So this is 2.37034368 e to the negative 11th power, okay? So hopefully what you realized was this. The original amount of air left in the lungs is 0.0000000000024 milliliters. All right, what about this? Take 400 milligrams of ibuprofen, that's about 2 Advils. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen is left after 6 hours? Remember, T is going to be time in hours for this one. Since it is decreasing, you are going to subtract 29%. But hopefully you realize that that needed to change to 2900ths. That seems to be a recurring theme here, Mrs. Rose. And you do the math. You do the math. And when you finish this, the amount of ibuprofen left after 6 hours is about 97 and 3/10 of a milligram. Notice that I went ahead and increased it to 3/10 of a milligram. It would have also been acceptable to say that it is approximately about 97 milligrams. Oh, so this is the toughie. And hopefully for the toughie, you remembered that you had to use this, the compounded interest formula, and the fact that when you have a rate, you had to divide the rate by the number of segments that a year has been broken into, and then raise that to the power of the number of segments times the number of years, okay? And so we have an account paying 2 5/10% interest, compounded monthly, and you would have used that formula, and you would have gotten an answer of about $1,724.48. For this one, compounded quarterly, you would have gotten $1,686.05. But for 4% annual interest, you would have gotten $1,799.78. Hope you've had a great day. See you again tomorrow.